Okay, morning everyone, it's Miss K. So we're doing a video on quadratic sequences, which is part of the new GCSE spec. So here are the 4 outcomes you're going to need to know for the video. You're going to need to know how to record the nth term of a linear sequence to enable us to do the later on much harder quadratic sequences. Okay, this slide's a quick warm-up. So let's just work through these questions. So what we have is 1n squared, and we're going to substitute n equals 5. So just remember what that means is substitution is a replacement of a number. So instead of writing n, I'm going to write this 5, and it's being squared. Between the 1 and the n is a multiplication. The rules of BidMath tells us to do the indice first. So 5 squared is 25. So it's 1 times by 25, and our answer is just 25. Okay, next question. Question 3, we're going to replace n, substitute in n to be 3 in this question. So that's 2 times by 3 squared. I do my indice first, so 3 squared is 9. 2 times by 9 is therefore 18. Third question, we're going to sub in now n to be 4. I do my indice first, so it's 3 times by 16, and that equals to 48. Alright, okay, so now in this video, so you need to know you're able to do this for the later part of the video, is to find the nth term of a linear sequence. If it's linear, the sequence it should be going up in equal amounts, so just check. That's a plus 2. Again, we have a plus 2. And again, we have a plus 2, so we can confirm it's linear. As it goes up in 2's, the nth term, which is a formula to generate any term in the sequence through substituting the position in, we will, as it goes up in 2, that implies there's a 2 in front of the n. Now there might be a number over here, either with plus or minus. Now to determine what number could be there, what I need to do is look at my first number of the sequence and then go backwards. So what would have been the number before? So we're plussing 2 to go forward, then we're going to minus 2 to go backwards. So 5 minus 2 is 3. So therefore this reveals the number that is going to be next to the 2n. It's a positive 3 because it's a positive 3 here. Okay, that's the warm-up done. Now we're going to go and look at some quadratic sequences. So let's look at the first worked example. In order to determine if a sequence is quadratic, what you want to do is just check the difference of the terms. So 7 take away 4 is 3. So the first 2 terms have a difference of 3. But the difference between 7 and 12 is 5. The difference between 19 and 12 is 7. The difference between 28 and 19 is 9. Now, this is called the first difference. Now, this sequence is not a linear sequence which would go up in the same amount each time. But with this sequence, it's going up in different amounts. So what that means is that I'm going to go again and look for a second difference. So this is my first. Let's have a look at the second difference. So that means the difference between 3 and 5 is 2. The difference between 5 and 7 is 2. And the difference between 7 and 9 is 2. So now these are all the same. So when we have a second difference, it means the equation is quadratic. A quadratic equation or quadratic nth term will have a thing called n squared in its formula. Now let's read this keynote because this is going to be very important. Halving the second difference tells us the number in front of the n squared. Okay, so let's just have a look at that keynote. So in other words, we know that there's going to be an n squared in the formula, by halving the second difference, which is 2. So halving means to divide by 2. That reveals the number in front of the n squared. So in this case, in the formula, we're going to have a 1n squared. But then we're going to need to inspect what are going to be the other aspects of this formula. So let's have a look. So we've already established that 1n squared is part of our formula. And here is our sequence. The first term, it gets substituted into a formula and generates 4. The second term gets substituted in a general formula to give me the second term. The third term, the fourth term. So I've presented my quadratic equation, quadratic sequence like this. Okay, so let's have a look at that. So if I start substituting the positions in, I want to generate 4. So I already know that this exists in my formula. I know it's a quadratic because it contains an n squared. I know there's a 1 in front of it because I've halved the second difference, and that half of the 2 is 1. So let's have a look. So I do 1 multiplied by, now my first position is 1, so I'm going to substitute 1 into this formula. So that's 1 times by 1 squared. Well, 1 squared is 1, and 1 times by 1 is 1. Okay, let's do the same for the second one. I'm going to now replace into the first part of the formula 1 times by 2 squared. 1 times by 2 squared is 4. Third stage is 1 times by 3 squared, which equals to 9. The fourth term, if I substitute the fourth term into the part of the formula that I've got, then I've got 1 times by 4 squared, which is 16. Okay, now just by looking at these, at the sequence so far, I've got 1, 4, 9, 16, and it's not yet giving me the output values that I want, which is 4, 7, 12, and 19, part of my formula. So now I'm going to inspect what has happened to these numbers in addition to get them to these numbers. Now let's just quickly check. If I have 1 here and I add on 3, I get the 4. If I take 4 and I add on the 3, I get 7. If I take a 9 and I add on the 3, I get the 12. If I take the 16 and I add on 3, I get the 19. So now the formula works. So the formula is 1n squared plus 3. So the nth term is n squared plus 3. So this formula will be able to connect the positions to the terms of the sequence. So if we wanted just to test the fifth term, because we haven't included it in our sequence here, we're going to do 5 squared plus 3. Well, 5 squared is 25. By adding 3, I get 28. So now I know that this actually works. Okay, so our nth term is n squared plus 3. We don't need to write the 1 there, but when you're doing the exam question, you want to state 1 so the examiner knows that you've understood about the second difference and halving. Okay, another worked example. You can either pause the video and have a try, or just work through this one and have a look how it's done. So first of all, we want to establish, is this a quadratic sequence? So in order to find out if it's a quadratic sequence, we're going to just check if we have a second difference. Okay, so we can see there is a first difference there, which is not the same, and by checking, we can see, yes, there is a second difference and it's going up in the same amount. So now, yes, I've got an n squared in my formula. So just previously, what I'm going to do with this second difference, which is 2, I'm going to half 2, so I'm going to do 2 divided by 2, and that reveals that there is a 1 in front of the n squared. Remember, the examiner wants you to show this in your working out. So let's go back to the sequence. So I know already that there is a 1 squared. Now I've already worked this out previously for you. So I already know by substituting the first term into the formula that I've got so far, I get 1, 4, 9 and 16. If I want to get the sequence, okay, what I need to do is just quickly inspect, or what do I need to do to 1 to get to 3, to 4 to get to 6, to 9 to get to 11, and to A16 to get to 18. If you've already worked it out, you should realize actually it's just adding 2, and it works. So if I add 2 to each of these, I get the numbers in the sequence. Okay, let's just quickly look. So therefore my formula is 1n squared plus 2, but I'm not going to write the 1 there because now it's unnecessary. But I have shown the examiner that I've understood it was 1. If you want to double check if it works, we'll take the fifth number of the sequence, 5 squared plus 2. 5 squared is 25, and plussing the 2 gives me 27. Okay, so that's worked example 2. You've got questions now for you to take a look at and see how you get on. So you can pause the video at any stage and try these ones out, or just continue to play to watch the answer reveal. Okay, so what I've already worked out is that I've looked at these numbers and I've worked out that the second difference is 2 for both of them. Okay, what do you need to do to the second difference? You need to halve it, and that will tell you that you get 1 in front of the 1n squared. So all you need to do now really is look at your formula so far. Are you generating the numbers of the actual quadratic sequence? You can say no, but then you just inspect what do you need to do extra to make sure you get these numbers. So if I have 1, by plussing 4, I get 5. Does plus 4 work for each of them? 4 plus 4 is 8, 9 plus 4 is 13, 16 plus 20 is 16 plus 4 is 20. So my formula is, for my nth term, is n squared plus 4. Well done if you got that right. You can give yourself a tick. Okay, similar situation over here. I saw that my second difference was 2. I'm therefore going to halve the 2 to actually reveal the number in front of the n squared is 1. This is really important because when we do harder questions, the number may vary. Alright, okay, so we've got 1, 4, 9 and 16. I need to decide what number I'm going to add on each time to get the actual numbers in the sequence. If you've got it, it's plus 7. You can double check that. Yes, if you plus 7 to each of these numbers, you'll actually get the numbers, the terms of that sequence. So my formula, my nth term is n squared, because I don't need to write the 1 now, and I'm going to plus 7. Okay, so that was the first stage. Now we're going to look at some slightly harder questions on the next slide. Okay, so let's have a look at this sequence here. And it's 7, 13, 23, 37 and 55. So what I'm going to do is quickly just work out the first difference, inspect if it is a quadratic. They might ask you to firstly check that the sequence is quadratic, and how you would do this is just explain that you have a first difference which is going up in unequal amounts, and therefore there's a second difference, and that second difference is going up in equal amounts. Right, so I can now I've now established it's a quadratic because it has a second difference that's going up in equal amounts. There's going to be an n squared in my formula, and the number in front of the n is actually now 2 this time, because we've already said if you halve the second difference, you will get 2, which is this number in front of the n squared. Alright, okay. So now we've established that, we're going to go into the second slide, the second bit now, and look at the numbers. Okay, so if I've already said that there's a 2n squared, now we know there's a 2n squared in our formula. By plugging in the positions of the number into the formula so far, we're going to see what we generate. So this is 1 squared is 1, times by 2 is 2, 2 squared is 2, 2 squared is 4, 4 times by 2 is 8, 9 squared is 3 squared is 9, 9 times by 2 is 18, and 4 squared is 16, 16 times by 2 is 32. Right, now we're going to check what do we need to do to these numbers to ensure we actually get the terms of the sequence. So if you got it, we're plussing 5 each time. And then you'll just check, is that true? 8 plus 5 is 13, 18 plus 5 is 23, 32 plus 5 is 37. So now we've got the components of our sequence, and so the nth term is 2n squared plus 5. Okay, and then you can always check if that's right by just sticking the fifth term. So if you stick 5 into the formula, 5 squared is 25, and if you double 25, that gives you 50, and if you take the 50 and you add on 5, that gives you the 55. Yeah, it's always useful to just double check. Okay, so now you're going to try some, so you can definitely pause the video and have a go. Right. Okay, so let's just quickly check with our second difference. We've got our first number to be 15 here. Got 25, 35, and 45. Okay, the second difference is 10. So our second difference is 10. Okay, which we can see, 20 difference between 25 and 35 is a 10, difference between 35 and 45 is a 10. So what that means is that you're going to half, half 10 to give you the number in front of the n squared, because we know it's quadratic sequence, and then we're going to plug in the positions of the number into the formula so far. So we've got 1 squared, which is 1, times by 5, which is 5, 2 squared, which is 4, times by 5, which is 20. Then we've got this 9 times by 5 over here, which is 45. And then we've got this 5 times by 16, which is 80. Okay, so just quickly let's check in addition what's happening. I've got 5, this time it's dropping down to 0, 20 drops down to 15, 45 drops down to 14, 80 drops down to 5. So if you've guessed it, yes, what's actually happening is that we are minusing 5. So piecing the formula together, our nth term is 5n squared minus 5. And so therefore it becomes a lot easier. Okay, so question 2. I've already worked out the second difference, and the second difference to this sequence is actually 6. Okay, so you can work that out and just double verify that it is 6. Now what you do is you take the 6, you divide it by 2, and that reveals the number in front of the n squared. So this is what we've come to so far. So we've got I'm going to work these out. 1 squared is 1, times by 3 is 3. 2 squared is 4, times by 3 is 12. 3 squared is 9. 9 times by 3 is 27. And then we've got our final answer to be 48. Okay, so the next thing you're going to see, again, it's another sequence that's dropping down. So what you want to just quickly check, actually, we're going down by 2 each time and just verify that with all the numbers, and that's true. So just piecing the sequence together is actually, the nth term is 3n squared minus 2. Okay, now we'll go to the next slide, which is some even harder questions. Okay, so now this one's a little bit more complicated to follow, so please pay attention. We've got sequence 4, 14, 30, 52, and 80. Let's just quickly verify. If we have our number in front of the n to be 3, that implies our second difference is 6. So let's just verify that. We've got the first difference to be 10, 16, 22, and 28. And just verify that. Yes, it's a difference of 6. Yes, it's a difference of 6. Yes, it's a difference of 6. And this confirms by taking the second difference, halving it, I have 3n squared as part of my formula. Okay, so let's just do the working out, and I think we had a similar questions on the previous slide. So just by substituting these values into this, you should get 3, 12, 27, and 48. So similar to the previous slide when it comes to these numbers. Now let's quickly verify and check what do we need to do to get from 3 to 4 to 12 to 14 to 27 to 30 and 48 to 54. Well, to get from 3 to 4 I need to plus 1. For the second one I need to plus 2 this time. And for the third one I need to plus 3. And for the fourth one I need to plus 4. So now we know it's not going up in equal amounts, okay? But I can see that there is a pattern. So if I was generating the fifth number, I could tell that I would need to plus 5 at this stage, at the second part of the formula. And if I wanted to find the 20th number, I would need to plus 20 at this stage. So I've got to generalize that with a rule. So if we look at these, if you remember what we talked about in the starter about linear sequences go up in equal amounts. Well, let's just take these numbers aside and treat them like a linear sequence. What would be the nth term to this linear sequence? Well, it goes up in ones each time, so therefore next to the n is a 1. What would have been that number previous to the 1? And that would have been 0. Okay, so that means you would plus 0. Well, there's really no point in plussing 0, so we could actually say the nth term to this formula is simply just n. So if I'm looking for the fifth term if I'm looking for, then I would substitute 5 into the formula, which is just n, and that number will give me 5. Okay, so what we're in effect doing is adding on n. So for each time we've calculated this stage, I'm just going to add on the position, which is n. So the nth term to this sequence is 3n squared plus n. Okay, so you may want to verify this because it's a bit tricky to first understand, is that if I want to generate the fifth term, the fifth number here, I'm going to replace it into my formula. So I've got 3 times by 5 squared, which is 25, and then I'm going to plus 5. Let's just verify that. 3 times by 25 is 75, and 75 plus 5 is actually 80. So this is my answer. Yes, so it has been in an exam question before where you need to generate the nth term of this. So do work through the video again. You can go back and just double check this part, your understanding. Okay, so what we're going to do next is have a look at this sequence, which is 6, 11, 18, 27, 38. We verify that the second difference is actually 2. So if it is 2, that means we're going to halve it, and the number, if we halve 2, it's 1, and that's the number in front of the n squared. So let's just replace the values into the formula so far. So we would have 1, 4, 9, and 16. And now what we're going to check is we're going to inspect what is happening between 1 to 3, 4 to 6, 9 to 11, and 16 to 8. And that's just plussing 2 each time. So this one's not so complicated. So this is just 1n squared plus 2. Okay, which is, you don't need to write the 1, but we may have already worked through that example. Okay, so what I've got is some questions for you now to have a try. You can pause the video and check if you've understood these questions. If not, then continue to play. These ones should be the harder questions. So let's just quickly work out. The second difference is 2. So let's just write down the second difference is equal to 2. So if I know it equals to 2, I'm going to halve 2. That's going to give me 1, and it's going to give me the first part of the formula, which is 1, 4, 9, and 16. Okay, what I will then do is just verify what has happened between 1 to 0, 4 to 15, 9 to 40. These are not correct, are they? So let's get rid of these. So what happened between to 1 to get to 1? 2 to get to 7, and 15, and 25. Okay, so these are our values we're trying to get to. Okay, so for me to get to 1 to 1, nothing's happened. I've added on 0. For me to go and get to 4 to 7, I've added on 3. I can verify that. For me to get to 9 to 15, I've added 6. And for me to get to 16 to 25, I've added on 9. Now, as my new sequence, what I need to add on is varying in amounts, but it goes up in threes. So therefore, let's just take the sequence aside. So if we have 0, if it goes up in threes, we know the second part of the formula is going to contain a 3n. Okay, now just remember, if we're starting off with a linear sequence of 0, 3, 6, and 9, what would have been the formula before? What would have been the number before that? And that would have been a minus 3. So the formula for the nth term for this is n squared plus 3n minus 3. Okay, now, so we'll do another one. Just remember that this is the actual sequence, so let's just get rid of this sequence 5 and 9 and 15. So let's work with those numbers, just correct this. Okay, so we've got our formula there, so whilst I was doing that, you could work out the second difference. Now the second difference, just to confirm, is actually 2. So my second difference is 2. So what that means is if I half 2, I get a 1 in front of the n squared. So let's plug in those values again. So the same second difference, so these numbers are going to be the same. And then I'm going to try and see what's happening with these numbers. Okay, so for me to get to 1 to 3, I'm going to add on 2, then I'm going to add on 1, and then I'm going to add on 0, and then I'm going to minus 1. Okay, so let's just verify what is happening with this sequence here. So what am I going to add on? So let's take these numbers aside because it might be clearer for you to read. Okay, so I've got a linear sequence which is 2, 1, 0, and minus 1. Okay, now what is happening each time I go along? Well, we could say we are minusing 1. Okay, if we're saying we're minusing 1 at each stage, that means the number in front of the n for a linear sequence is 1. Okay, but it's a minus 1 because it's going down by 1s. Now, what question you're going to ask yourself is, in addition, what's actually happening to the formula? So in order to work out what I add or subtract on, I look at the number that would have been before the 2. And that number is a 3. So that would have been the number before 2. So that number goes in front. That 3 belongs in at this point in my formula. So now to explain, to get from 1 to 3 to 4 to 5 to 9 to 9, 16 to 15, this follows this part of the formula, which is minus 1n plus 3. Now remember, we've already established it's a quadratic sequence, so this part of the formula will come down now to explain the quadratic sequence, which is just the 1n squared. So you could write down just n squared. Okay, so the formula to this quadratic sequence is n squared minus 1n plus 3. Okay. So what I'd like just see is just to rate your understanding. It gets a little bit complicated towards the end, but I do suggest that you actually rewatch that part again, because it is quite a challenging topic. Okay.